So we are going to learn about preparation of ammonia by HABER's process. Now, first of all, so you will see that in HABER's process, what actually happens is N2 reacts with hydrogen and NH3 is formed. This is a exothermic reaction. You can see heat released is minus 92 kilojoule per mole. Nitrogen from the air and hydrogen from natural gas in the ratio 1:3 by volume at a temperature of 400 to 450 degrees centigrade and 200 atmospheric pressure and iron catalyst. Okay, this information is required. It reacts to form ammonium. Now the catalyst is a pure iron. To increase efficiency, we can use K2O and Al2O3 as promoter. K2O and Al2O3 as promoter, or potassium hydroxide, as it can be seen from here. Pressure is 200 atmospheric pressure. Now, at each pass of the gas through the reactor, only about 15% of nitrogen and hydrogen converts to ammonium. By continual recycling of the unreacted nitrogen and hydrogen, the overall conversion is about 98%. Okay. So, we are going to see a video now.
To an industrial process in the early 1900s around World War I by Fritz Haber. And what Haber was after was ammonia so that he could fuel a war machine, so that he could feed and create explosives and ordnance for a very large German army. And in order to do this, in sort of an ironic twist, he used the idea of a French chemist, Henri-Louis Le Chatelier, who discovered, or more accurately, observed, that we could shift. The Haber process involves the reaction of 1 mole of N2 gas with 3 moles of H2 gas to form 2 moles of ammonia. And it's an equilibrium, and it's also a really tough reaction to get started. So Haber had to heat this reaction to 400 degrees centigrade and compress it to 200 atmospheres of pressure in the presence of an iron catalyst, all just to get that nitrogen-nitrogen triple bond to break and activate the reaction which formed the ammonia he wanted. So this reaction is a very disfavored equilibrium, even under these conditions. And what Haber most likely would do is sit down with his pen and paper, just like any good Gen Chem student would, and try to determine the amount that he would get at equilibrium from such a reaction. So let's do that.
So this process has is very important, and it has high industrial value because ammonia is required for preparation of many other components. So now this is the end.